Hi guys. So today we're going to review the thing that you did in every single unit last year in Algebra 2, and that is transformations. Some of these you also saw back in Algebra 1. So we're going to look at these in words, but also look at them as an example in an equation. So all of what transformations do is they change the way that the parent function looks. Now we saw some examples of this on the Desmos activity that we did in class, so you can look at that as well to help you out with this. So first we looked at horizontal changes. So horizontal changes happen inside our parentheses. They were near the x. And those were things that also were sometimes a little bit backwards from what we thought they would be. So a shift right. So for example, if I had, let's say I look at the quadratic parent function. Okay, so the quadratic parent function is x squared. So if I'm going to shift right, that would be x minus some number. So x minus 3, for example. That would be a shift right. A shift left, on the other hand, would be if I did x plus 3 inside the parentheses. Okay, so changing inside the parentheses is horizontal. Adding and subtracting is a shift. But if it's minus, it's going to go right. And if it's left, it's going to be a plus. Now, the horizontal stretch or compression, if you were in on level, you might not have seen this last year. But a horizontal stretch or compression is going to also occur inside the parentheses. But these are also backwards from what you would think it would be. The bigger number is actually going to be a compression, and a smaller number is going to be a stretch. So if that number, we'll call it b, if it's in between 0 and 1, it's going to be a stretch. If it's greater than 1, it's going to be a compression. So for example, this time I'll use square root instead of quadratic. Okay, so if it's in the parentheses, if it's near the x, so it'll be under the radical for a square root. So if it's a number like 1/2, then it would be a horizontal stretch. But if it's a number bigger than 1, like 3, then it's a compression. All right, and then a reflection over the y-axis. Okay, that would occur inside the parentheses, near the x. I'll use absolute value for this one. So I'll put it again inside, near the x. Okay, that would be a reflection over the y. So that one gets missed a lot. A horizontal change, think that it's flipping left and right. And if it were to flip from left to right, we would go over the y-axis. All right, now let's look at our vertical changes. Okay, so our vertical changes happen away from the x or outside the parentheses. So a shift up or a shift down, it's still going to be adding, but this time it's going to be outside. So for example, I would do f of x equals x squared plus 3. So it's away from the x and it's not inside parentheses. A shift down would be f of x would be x squared minus 3. A vertical stretch or a vertical compression. So I'll use the square root function again. So this time it's like normal, okay? If it's greater than 1, if it's a stretch, and I'll call it a because that's what you probably were used to seeing last year. And I'll call it a again. Okay, so something like this, the number 3 out in front. Okay, that would be a vertical stretch. Okay, a vertical compression would just be a smaller value, like 3/4, something that's less than 1. And then again, away from the x, outside the parentheses, okay, this would be a negative on the outside of the absolute value. Now, these transformations can look different depending on the function that you use. So for example, any of those that were quadratic, that could also be x cubed. Any of those that were square root, that could also be cube root. Okay, so it could look different depending on what the equation is. So to get a little bit of practice in, we're going to look at some of those parent functions, and we're just going to determine what the transformations are. So the first thing we're going to do is we're going to identify the parent function. Okay, so this first one, you see something squared. So that is the quadratic parent function. And then we're going to see the changes that it has. Well, the 1/2, that is out in front, away from the parentheses, so it's vertical. It's less than 1, so that is a vertical compression. All right, minus 2, that is a shift right. And plus 1, that is a shift up 1. All right, over here, this function, okay, on b, that is the square root parent function. The 2 out in front, that's a vertical stretch because it's bigger than 1. The negative is next to the x, under the radical, next to it, so that is a horizontal change, which means it's a reflection over the y-axis. Then that minus 3 is outside the square root, so it is a shift down 3. All right, looking at our next one, that one is also quadratic, and I'm realizing now I meant for that to be cubic. So I'm going to go ahead and change that to a 3 as an exponent. It will work the same way, though. It's just going to be a different parent function. So this is going to be our cubic parent function. It's got a vertical stretch. That's the 2 out in front. And it has gone left 3. All right, let's look at our next one. That one is a cube root. So it's like a square root, but it's got that little 3 there. That's how we know it's a cube root. The negative out in front, that's a change vertically, so that's a reflection over the x-axis. The 2 that's on the inside, that is going to be a horizontal, either stretch or compression. Since it's greater than 1, that is a horizontal compression. And that's probably the hardest transformation to remember, because it's backwards from what you think it's going to be. And then finally, that plus 1 is outside of that radical, so that is going to be a shift up 1. All right, looking at E, that is our absolute value function. That 3/5 out in front, that is a vertical compression. Okay, it's multiply out in front, but it is less than 1. Then x plus 1, that is a shift to the left 1. And finally, this last one gets actually confused a little bit because that -4 is right next to the x. But because of the way this is written, the x is the only thing that's being cubed. So since the x is the only thing that's being cubed, okay, we really could write it like this and put that x in its own parentheses. So that -4 is going to be a vertical stretch and a reflection over the x. Now, if it was a horizontal change, it would actually be written with parentheses like this, but it's not written that way. All right, and then the plus 7, that is going to be a shift up 7. All right, so what we're going to do now is just look at some of these graphically. Okay, so in the dotted line, you're going to see the parent function. So the first thing we do want to do is recognize what parent function this is. That first one, that parabola, that is the quadratic parent function, which is x squared. Then we're going to see how this graph has changed. Well, it obviously has shifted right, and it's shifted up. So we've gone right 2 and up 1, 2, 3, 4, 5. So since it's gone right 2 and up 5, that equation would be x minus 2 and plus 5. All right, looking at the next one, that's the square root parent function. Okay, so the square root parent function. And then let's see how it's changed. So we've gone up 2, and then it's been reflected over the y-axis. Okay, reflected over the y-axis. So if it's over the y-axis, then that negative is going to be under the radical. And then plus 2, since it's up, would be outside the radical. All right, this next one, that is our absolute value. It looks like a V. Okay, so the dotted line is the parent function. And then let's see how this graph has changed. Okay, well, let's look first of all. It's obviously been reflected. It's now opening down. That's a reflection over the x-axis. All right, the vertex has also moved. So that vertex has gone up 1, 2, 3, and gone left 1. So up 3 and left 1. So the way that we'll write this, so there's going to be a negative out in front to show the reflection. Then we'll have a shift to the left 1, so it'll be x plus 1 inside the absolute value bars. And then it's gone up 3, so we're going to put a plus 3 on there. Now, how this graph has also changed, if you'll notice, it looks a little bit narrower. So the question here then is, hey, is this a horizontal compression or is this a vertical stretch? And actually, you could write it either way. Now, I will tell you guys, for the most part, these are easier to write with vertical stretches and compressions. Horizontal stretches and compressions can be a little bit harder. So I'm going to write this as a vertical stretch. And I'm just going to see how this has changed from the parent function. Well, the parent function goes up 1 over 1, up 1 over 1, up 1 over 1. Well, looking at this one, I'm going right 1, down 2, over 1, down 2. So I'm moving twice the height. So this graph is 2 times taller than the original, so it has a vertical stretch by a factor of 2. All right, then looking at the last one, okay, that parent function, that is the cube root. Okay, cubic has a similar shape, but goes this way. So that is the cube root parent function. And then you can see it hasn't really been shifted at all. Okay, so it still has the same middle point there inside of it. So the way that this graph has been changed has been either a vertical stretch or compression. So this graph has been stretched vertically. Okay, so let's see how much it's been stretched vertically. Well, on the dotted line, we went right 1, up 1 to get to that point. Well, on the solid line, I went right 1 and I went up 1, 2, 3. All right, and if I went even further, I would see that I went over 8 to go up 2, and I went over 8 to go up 6 if I hadn't cut this graph off where I did. So you can see the height is 3 times as big as it was. So it's been stretched vertically by a factor of 3. So this is 3 times the cube root of x. All right, so if you were able to write those equations from the graphs, this next part's going to be pretty easy because all you're doing in this next part is writing the equation now. All right, so we're going to have a cubic function. Okay, so a cubic function, that's x cubed. It's been vertically stretched and shifted right. So there's a lot of different ways you can do this. The number out in front needs to be greater than 1. So I'll do 2. And then we need something in parentheses to know that it's shifted right. So this will be x minus 1. Or you could do x minus 7 or any number as long as it's x minus. That's a shift right. All right, absolute value. Those are those straight lines. Okay, so reflected over the x-axis, okay, that's going to be a negative out in front. So that's absolute value of x. Shifted down, that's going to be a minus. That's going to be on the outside. So minus, let's say 10. All right, and then last one, square root function. So the square root of x. All right, reflected over the y, that's going to be a negative inside the radical. Horizontally compressed, that's going to be inside the radical. And also remember, if it's compressed, that number is going to be greater than 1. So any negative and any number greater than 1. So 2, 3, 4, you can pick. I'll do 4. And then we want it shifted up, so that's going to be a plus outside of the radical. All right, so that is a little bit of a review over transformations. Again, remember, the horizontal stuff is going to be in the parentheses near the x. The vertical stuff is outside the parentheses.